So classified paper 6, topic acid, alkali, and salts. Question 7, a student investigated the reaction between aqueous sodium carbonate and a barium nitrate. A burette was filled with an aqueous sodium carbonate initially, and 7 test tubes were labeled 1, 2, 3, 4, 5, 6, and 7. And a measuring cylinder was used to pour a 6 cm cube of a barium nitrate. So in a test tube, we have 6 cm cube of a barium nitrate. Then we add 1 cm cube of sodium carbonate in the first one by using from a burette in test tube 1, then 2 cm cube, then 4, 5, 6, 7, and 8. For those who just joined now, this is classified paper 6, question 7 from topic acid, alkali, and salt, page number 80. A glass rod was used to stir the content in each of the test tube, and the content of a test tube were left to stand until a solid form. Because what will be the solid form? You have a sodium carbonate is there. So what we have sodium carbonate and we have barium nitrate. So as a result, what will happen?
It will be barium carbonate and sodium nitrate. Sodium nitrate is soluble and barium carbonate is insoluble.
So barium carbonate will result in a formation of the precipitate. So different, and we add different amount of sodium carbonate in different test tubes. You can see, use a ruler to measure the height of a solid form in each test tube. So in this, you have to use your scale, a ruler. So I will write the answer for this. You have to place a ruler and measure these height of the precipitate. You have to measure. First, the volume of a sodium carbonate used, that part you can fill up. The volume of sodium carbonate used, you can see 1, 2, 4, 5, 6, 7, and 8. That you can do. You can complete this row about the volume of sodium carbonate. About the height of a solid which is formed, so you have to place your ruler, scale, and measure this height. And that is, as you can see, the scale that is in millimeters. So you will get answer in centimeter. Just multiply by 10. You will get the answer in millimeter. About the height, because you cannot fill up now, as it related to the measurement, you have to measure and then. So I will just write the heights, approximate heights of the precipitate. So it is like the first one is about 1.2 centimeter or 12. So first one is about 12. The second one is 24. Then the third one is 48. When you measure the height, then we have 60. And this you have to just use your ruler and measure the last three. It's 73 for all of them. And we measure, like it will be 7.3 centimeter or 73 millimeter. So you just have to place your ruler scale next to the test tube and measure the height of the precipitate which is formed, or height of the solid form. The marking scheme answer for the height, it will be, for volume it will be same, but for height, yes, it will be different because it depends on the scale from which you printed out. So that's why the height will be different. Plot the results on the grid. Draw two intersecting lines of best fit and label the x-axis. So on y-axis, we have the height of the solid which is formed. So what should be there on x-axis? So on x-axis, because it will be a volume of a sodium carbonate, as this one was there. How much sodium? 1, 2, 4, 5, 6, 7, and 8. So we have the volume of sodium carbonate, and labeling the axis is having a mark. So this one is volume of Na2CO3, and that is in centimeter cube. And what are the results? The experiment one, volume was 1, then 2, then 4, 5, 6, 7, and 8. And what were the height of the precipitate? Was 12, 24, 48, 60, 73, 73, and 73. So we have to mark those points. So first, this one is the volume. The second one is the height of precipitate. So when the volume is 1, the height, each box here, 20 boxes, like 20, 10 boxes equals to 20. So each box is 2. So this will be 2, 4, 6, 8, 10, 12. So this is 12. Then 2 and 24. So this one is 2, 20, and then 2 boxes above, that will be 24. 3 and 48. So this one is 3, 42, 4, 6, and 8. So this is 48. Then 5 and 60. So this one is 5 and 60, this point. So this looks 5 and 60. Then we have 73, 6 and 73. So this was 60, 4, 6, 8, 70, 72, 4. So this will be 73. And then 7 and 73. And then 8 and 73. So these are the points. Now, whenever you are plotting a graph, if some of the lines or some of the points appear to be anomalous, you will ignore them. Now, we have to draw 2 intersecting straight lines. Let me just reconfirm the point. This was actually 4 and 48. So I should make it here. 42, 4, 6, and 8. So this is 48. So we have to draw 2 intersecting straight line. First one, this one is the first one. And this one is the second. So these are the 2 intersecting straight lines. You can start from origin as well, this line. So this is representing like 2 intersecting straight line, and best fit straight lines are there, and we already labeled the x-axis. Then the next part of the question. From your graph, reduce the height of a solid form with 3 cm cube of sodium carbonate and describe the trend in height of a solid form from test tube 1 to test tube 7. So first we have to deduce the volume, the height of a precipitate form. If we use 3 cm cube of a sodium hydrogen carbonate or sodium carbonate, so we draw a line from 3 cm cube and find the height of the precipitate. So each is representing 2 boxes. So each box is representing 2. So this is 2 boxes below. So that is equals to 36. So height of the precipitate when we are using 3 cm cube, that is equals to 36. And what is the relation between, the next question is, what is the relation between the volume? So we write here 36. Then describe a trend in the height of a solid form in test tube 1 to test tube 7. What is the trend? How they are related to each other? Can you relate? How you can make a relation between the height of the precipitate and the volume of sodium carbonate used?
It can be directly proportional.
It can be directly
correlation.
Positive correlation, or you can also mention like as the volume of a precipitate, volume of sodium carbonate is increasing, the height of the precipitate is also increasing, and then it level off, become constant. So 2 points
If
you
it
have.
start from origin, then we can say directly proportional.
Yeah, so as the volume increases, the height of the precipitate increase until the height levels off. So this point, why it's of 2 mark, 1 mark is for mentioning as the volume increases, the height of the precipitate also increase, and then later the height level off, or there is no change as we increase the volume. So 1 mark is for showing that if you are increasing volume, height is increasing, height of the precipitate is increasing. Eventually what happens? Further increase in volume, there will be no change in height of the precipitate.
This means sodium carbonate becomes in excess.
In excess, yeah. Sodium carbonate become in excess. That's why the precipitates are not forming more. The next one is predict what would happen if experiment was continue until using 3 further test tube, which contain 6 cm cube of barium nitrate and separately adding 9, 10, and 11 cm cube of sodium carbonate. Like in the beginning, how much sodium carbonate was there? How much barium nitrate was there? 6. Now they are saying if we continue this experiment, if we further carry out the same experiment, and now we are adding 9 cm cube of sodium carbonate, then we add 10 cm cube of sodium carbonate, then we add 11 cm cube of sodium carbonate. What will happen to the precipitate? Will it change?
No.
So there will be no change in the precipitate because already barium nitrate is completely used up when we carried out the experiment. So till like
it is seen in the graph that it becomes in excess.
Yeah, it became in excess. So there will be no further changes there in barium in the height of the precipitate or amount of precipitate. So it's of 2 marks. How you score the 2 marks? Number 1, you will mention the height of the precipitate does not change. And why? Because all the barium nitrate is already reactive. Or you can also say other way around, you can say that sodium carbonate is in excess. So no change in the height. And what is the reason for that? Because barium nitrate is used up. Suggest one change to the apparatus which could be made to obtain more accurate result. What change and whenever a question is there related to change in apparatus, so you should always read the first part of the experiment, like the things which we use for this experiment. So what are
we
the
used
things?
a burette, we can say.
No,
we use measuring cylinder.
Measuring cylinder. Burette is already like one of the solution was added. A burette was used, so there was a burette used for sodium carbonate, so this will be accurate. But if you check, a measuring cylinder was used to put 6 cm cube of barium nitrate. This won't be accurate because a measuring cylinder is measure approximate volume, and it is just to transfer quickly rather than accurate measurement. So what we can do, what change to the apparatus can be made for accurate results? So we will use We cannot say pipette here. Reason for that because we
Pipette
are
can only measure
fixed volume.
25 centimeter cube. No range is there.
No range is there. So suggest one change to the apparatus. So what change to
Burette.
apparatus we can do? We can use burette to measure the volume of barium nitrate. So a burette can be used to measure the volume of a barium nitrate. Suggest a different method to measure the amount of a solid form during this experiment. Like what we did here, one way of measuring the amount of a solid form. Yeah, one way of measuring the amount of solid form, what we did, we measure the height. What is the other technique can be used? You can measure the weight, but it's of 3 marks. So you should be accurate, like you should mention the points experimentally, how we can measure the weight of this precipitate. So first, what we should do, we should filter.
Filter
Then we
it
should
and
dry.
wash with.
Filter, wash, dry, and then weight the precipitate. So that's why it's of 3 marks. Instead of measuring a height, we can also measure the weight of the precipitate. So first we should filter, then we should dry the precipitate, filter, wash, and then dry. Because whenever precipitate or insoluble salt is produced by precipitation reaction, we wash and dry, and then we can weigh the mixture, the precipitate. Suggest how the reliability of a result could be checked. Whenever you want to check
Repeat
whether your
and
results.
spot for anomalous result.
Yeah, whenever reliability of a result you want to check, you should always repeat the experiment.
Repeat and check if values are in range.
Yeah. So repeating the experiment and compare the results, or even plotting graphs can also identifying the anomalies. So repeat the experiment and compare the results to check anomalous results or check the reliability of the results. Because this was insoluble salt, that's why we were using a filter, washed and dry. Insoluble salt never, like as they're insoluble, so the salt will not dissolve.